Our today's topic is full wave bridge rectifier with R load. Now this is the circuit diagram of full wave bridge rectifier with R load, and this is fully controlled. That means all the element in that bridge is controlled element like thyristor. So this is thyristor T1, this is thyristor T2, this is thyristor T3, this is thyristor T4, and with R load, that means resistive load. This is R. Current flowing through this load is I0 and voltage across this load is V0. And this is our supply voltage. Vs is equal to Vm sin omega t. Now at positive half cycle, current flowing through T1 and T4. That means T1 and T4 are conducting at that time, and in reverse bias T2 and T3 are conducting. So first positive half cycle current flowing through this manner, and at the time of negative half cycle current flowing through this manner. Okay, now the waveform. So this is supply voltage waveform. Vs is equal to Vm sin omega t. Now we can apply triggering after alpha degree. So this is full wave rectifier. So we can apply alpha T1 and T4, and after 180 degree we can also apply alpha at T2 and T4. So all the wave half cycle are to be controlled. So suppose this is alpha degree, we can apply alpha negative half cycle also. In every cycle we can apply alpha degree triggering angle. On this alpha we can, this is alpha degree, this is Ig, this is Ig, this angle is alpha, this is 0, this is pi, this is 2 pi, this is 3 pi, this is 4 pi. Now the resultant or output voltage waveform across our load. If we use diode in case of thyristor, then average voltage output voltage waveform like this, but this is thyristor. There is the alpha degree triggering angle, so average voltage waveform like this. This is V0. And similarly, this is the we use resistive load. So current waveform is like this, because in case of resistive circuit, current and voltage are in same phase. Now this is also the current waveform also. Now we can draw the voltage across thyristor. Voltage across thyristor. So first we can draw voltage across thyristor T1 and T4, and then we can draw the waveform of T2 and T3. So V T1 T4. V T1 and T4. In this position, the voltage is present across T1 and T4. Then we can apply triggering angle. Then voltage will be 0, near about 0. Some voltage from across there in thyristor like 0.7 or 0.8 volt. And then after this voltage across T1 and T4 nearly about 0, then we get this voltage, but that time T4, T2 and T3 are conducting. So first of all, this is the voltage, then this voltage nearly about 0. This is not theoretically about 0. After this position, when this position, the voltage across thyristor T1 and T4 like this. Like this, and the voltage across T2 and T3 are like this. Voltage across T2 and T3. Voltage across T2 and T3 is reverse manner. That is, this is in reverse manner. That is, it is the voltage across T1 and this is the voltage across T2 and T3 like this. Now the average output voltage, expression of average output voltage. So V0 is equal to V0 is equal to this is one cycle. So average value we can take, this is pi, this pi, 1 by pi. Now this is alpha, and this is pi, and this is pi plus alpha. So we can take the lower limit is alpha and upper limit is pi plus alpha Vm sine omega t, that is supply voltage d of omega t. Now 1 by pi, that is Vm by pi, minus of cos omega t alpha or pi plus alpha. So Vm by pi minus of cos pi plus alpha minus of cos alpha. So Vm by pi minus cos alpha means cos alpha plus pi means cos pi, cos alpha plus sin pi sin alpha plus of cos alpha. Now sin pi is equal to 0. So this equation goes to 0 and cos pi is equal to minus of 1. So minus minus plus. So plus cos alpha, that means 2 Vm by pi cos alpha V0 is equal to. And similarly, the expression of output current, average current I0 is equal to 2 Vm by pi into R means resistive load into cos alpha. That's all.